Other question of the semiconductor and semiconductor devices: calculate the current through the circuit and the potential difference across the diode. The drift current for diode is 20 microampere. So just this diagram is given. This definitely, this is the positive and negative of the diode, and here the negative and positive of the battery. So here positive is connected with the negative, that means it is in the reverse bias, reverse biasing, and here the external resistance 20 ohm, and drift current is also given 20 microampere. So first part, current in the circuit will be equal to the drift current and that is in the reverse biasing. So that is equal to 20 microampere, कोई चेंज नहीं, राइट, करंट जो दिया है वही होगा. अब यहाँ पर पोटेंशियल डिफरेंस अक्रॉस द ड्रिफ्ट अक्रॉस वी हैव टू फाइंड अ पोटेंशियल अक्रॉस द डायोड. डायोड के अक्रॉस पोटेंशियल डिफरेंस हमको निकालना है. सो पोटेंशियल डिफरेंस और वोल्टेज अक्रॉस डायोड will be, as it is a reverse bias, so 5 volt minus क्या हो जाएगा, I into R, this particular part का external is I कितना इतना into R. So I is your 20 micro means 10 to the power minus 6 into R 20. So that comes out to be 5 volt minus that is your 400 into 10 to the power minus 6. 10 to the power minus 6. So if you are going to calculate 5 minus 0.0004 itna volt, that is, this is a very less amount, so we can write it, this is approximately equal to 5 volt. That should be your answer. As it is very less, if you are going to subtract it, it is 4.999 itna something. So approximately, as it is very negligible, so it is approximately 5 volt. Another interesting question, each resistance in the circuit is 20 ohm. Find the equivalent resistance between A and B. A और B के बीच हमको क्या निकालना है, ये 20 ओम है, ये भी 20 ओम है, ये भी 20 ओम है, 20 ओम है. ए और बी के बीच हमको पोटेंशियल डिफरेंस निकालना है, सॉरी इक्विवेलेंट रेजिस्टेंस निकालना है, आर इक्विवेलेंट बिटवीन ए एंड बी. So if you are going to see it properly, it is very much resemble the Wheatstone bridge. Wheatstone bridge. And Wheatstone bridge, if the P by Q, the balance condition is equal to R by S, means the ratio is same, 20 by 20, 20 by 20, ratio is same, then the no current is going to pass through this. इससे कोई करंट नहीं पास करेगा. If this is a balance condition, how it is going to be understood as it is a balance condition? Because P by Q is equal to R by S, that ratio should be same. अगर रेशियो सेम है तो यहाँ पर सेम है, तो नो करंट passes through डायोड. डायोड से कोई करंट पास नहीं करेगा. तो देयरफॉर अब ये सर्किट कैसा बन गया, अब ऐसा बना सकते हैं, ऐसा बन गया ए बी, ये 20, ये 20, ये 20, ये 20, मीन्स 20 20 40 ओम and this is also 40 ohm. So R equivalent will be 40 into 40 by 40 plus 40. That comes out to be ये हो गया 1600 by 80. So काट दिए, that is 20 ohm. That should be your answer. Right? Another question, a doped semiconductor has impurity level of 30 milli electron volt below the conduction band. Part A, is the material is N type or P type? Number B, in the thermal collision, an amount kT of energy is given to extra electron loosely bound to impurity ion, and this electron is just able to jump into the conduction band. Calculate the temperature T. So first part is that just below the conduction band, that means here the number of electrons is very much closer to conduction band. So here the conduction electron is a populated, or we can say populated where? Near the conduction band. So we can say this is the N type of semiconductor, right? Electron is much more electron is near the conduction band, so it is a population, or you can say the number of electrons is more, so we can say this is the N type. Second part, given the extra energy loosely bound to the impurity ion and the electron is just able to jump in the conduction band. Calculate temperature T. So here, according to the question, K into T is equal to 30 milli electron volt. That's the amount of energy kT, where K is the Boltzmann constant, T is the absolute temperature. So we have to find the T. So T will be 30 milli electron volt by K. So by putting the value of K, which is 8.62 into 10 to the power minus 5 electron volt Kelvin to the power minus 1. So we can write it, this milli is there. So 0.03 electron volt by K ka value 8.62 into 10 to the power minus 5 electron volt Kelvin to the power minus 1. So if you are going to calculate, I am using the calculator, so its value is around 348 Kelvin. That should be the absolute temperature that is required. Another question of that IV characteristics of PN junction diode. Question is, the IV characteristics of PN junction diode is given in the diagram. Find the approximate dynamic resistance of the PN junction when a forward bias of 1 volt is applied, and second part, a forward bias of 2 volt is applied. This is a diagram. See the diagram properly of the IV characteristics, I along the y axis and V along the x axis. Here this is a diagram. So here the first part is that 1 volt is applied, here 1, and the diagram is like that. If we have to find the dynamic resistance, the resistance of this particular part, and here also we have to find the dynamic resistance when this in the second bit. So dynamic resistance, we know first part, dynamic resistance is equal to change in potential difference by net current or change in current. So first one is 0.2 volt and del I is your 5 milliampere. Just to see the diagram once more, 1 and the difference is 0.2 volt, this particular part 0.2, and current difference is the 5 milliampere. This is in milliampere. So resistance is your you can say the P by B, tan theta slope. So that dynamic resistance 0.2 volt by 5 milliampere. That comes out to be 40 ohm. That should be your answer. Similarly, in the second part, again you have to find out the dynamic resistance del V by del I. Del V, just to see, in this particular case 2 to 2.1, difference in the potential is 0.1, and here difference in the current, this is a 400, and that particular part ends at 800. So 400 and 800, the difference is 400. This 800 minus 400, that is your, so we have to write 0.1 by 400 milliampere. That comes out to be 0.25 ohm. That is your answer.